In the freezing dawn of February 10, 1942, the United States Navy looked upon one of the most spectacular self-inflicted disasters of its transatlantic war. At Pier 88 in New York Harbor, a leviathan of roughly 83,000 gross tons lay capsized and half-submerged in the mud. She was the USS Lafayette, formerly the French superliner SS Normandie. The military had requisitioned the world's most luxurious passenger ship to solve a terrifying strategic crisis, moving a massive American army across a U-boat-infested ocean. Stripped of her sweeping Art Deco promenades, her 30-knot speed and immense internal volume were expected to let her carry as many as 16,000 troops across the Atlantic, often without a conventional escort, while making submarine interception extraordinarily difficult. She was the ultimate military prize, meant to be the backbone of the troop transport effort. Yet the mighty ship was utterly destroyed before she could carry a single soldier, and without a single enemy torpedo ever being fired. Her death was not an act of foreign sabotage. She was destroyed by a preventable hot work accident, compounded by inadequate fire precautions, disrupted shipboard systems, divided authority, wartime haste, and the immense weight of firefighting water trapped inside the hull. How did the United States Navy's desperate rush to transform a floating palace into the perfect warship ensure that she never even left the dock? In December 1941, the United States was violently thrust into a two-front global war. Instantly, the War Department faced a terrifying mathematical reality. To defeat Nazi Germany, America would have to project an army of millions of men across the Atlantic Ocean. But the Atlantic in early 1942 was a graveyard. German U-boat wolf packs were slaughtering Allied merchant shipping along the eastern seaboard and deep into the ocean corridors. The existing American transport fleet consisted largely of converted merchantmen and older vessels that plodded through the swells at an agonizing 10 to 15 knots. At that speed, a troop ship carrying thousands of American soldiers was nothing but a slow-moving target. The traditional naval solution to this tactical problem was the convoy system. Surround the vulnerable transports with a steel ring of destroyers, subchasers, and escort ships. But here lay the strategic trap. The United States Navy was already stretched to its breaking point, trying to halt the Japanese advance in the Pacific. There simply were not enough combat warships in the American inventory to safely escort an entire army to Europe without critically weakening the fleet elsewhere. To win the war, the military needed a way to move men that did not drain the combat fleet. President Franklin D. Roosevelt and his military planners found their answer by looking at their British allies. The British were successfully moving armies across the globe using the vessels commonly known as the Queens, the Titanic ocean liners RMS Queen Mary and RMS Queen Elizabeth. These ships relied on a radically different doctrine of naval survival: speed as protection. In 1942, a German Type 7 U-boat could manage roughly 17 knots while running on the surface and barely 8 knots while submerged on electric battery power. A standard troop convoy crawling at 10 knots gave a U-boat commander hours to plot an intercept course, submerge, wait in ambush, and fire. But the giant British liners could maintain sustained cruising speeds of 28 to 30 knots in the open ocean. At that velocity, the mechanics of submarine warfare completely broke down. Unless a U-boat commander happened to be sitting exactly in the direct path of the oncoming liner, he could never maneuver his submarine into a viable firing position. The giant ship could blast past and disappear over the horizon while the commander was still struggling to establish the geometry of an attack. A single fast transport could carry as many as 15,000 men in a matter of days, sometimes sailing independently and presenting submarines with an exceptionally difficult intercept problem, but never eliminating the threat entirely. If the United States Navy was going to deliver its massive new army to the front lines, it desperately needed a high-speed superliner of its own. But laying down the keel for a 30-knot, 80,000-ton behemoth would take at least 3 years, and the Allied war effort simply did not have 3 years to spare. Fortunately for the War Department, they did not have to build one. The perfect candidate was already fully constructed, heavily fueled, and sitting trapped exactly where the Navy needed her, right in the middle of New York Harbor. When the war erupted in Europe in September 1939, the absolute pride of the French line, the SS Normandie, had safely docked at Pier 88 in Manhattan. After the fall of France to Nazi Germany the following year, the magnificent 1,000-foot-long vessel remained interned in the Hudson River, idling indefinitely under the watchful eye of the United States Coast Guard. Following the attack on Pearl Harbor, the American government no longer had to ask for permission to use her. Acting under congressional authority and a presidential executive order governing foreign vessels in American waters, the government formally requisitioned the superliner, with compensation to be determined under United States law. American personnel assumed protective control of the ship on December 12, 1941. 4 days later, the United States Maritime Commission formally requisitioned her. She was subsequently transferred to Navy custody, renamed USS Lafayette, designated AP-53, and selected for conversion into an exceptionally fast, high-capacity troop transport. To understand why the Navy prized the ship so highly, one must look below the waterline to the work of her original designer, the Russian-born naval architect Vladimir Yurkevich. Shipbuilders had long studied how hull form and engine power interacted at high speed, but Vladimir Yurkevich pushed those principles in an unusually bold direction, seeking efficiency not only through power, but through the shape of the ship itself. Yurkevich rejected brute force in favor of pure hydrodynamics. He drafted a revolutionary hull featuring a hollowed, sweeping profile and a distinct bulbous bow extending just beneath the waterline. This bulbous forefoot altered the wave pattern around the bow, reducing wave-making resistance at high speed and allowing the immense hull to move through the Atlantic with unusual efficiency. Yurkevich's ultra-sleek hull was paired with an equally radical propulsion system, a massive turboelectric drive. Rather than connecting steam turbines directly to the propeller shafts through giant physical reduction gears, the ship used 29 massive boilers to spin steam turbines that generated immense amounts of electricity. This electrical power was then fed into huge electric motors that physically turned the ship's 4 propellers, producing a staggering 160,000 shaft horsepower. This engineering choice provided a clear strategic advantage. The turboelectric drive operated smoothly, allowing rapid power adjustments and minimizing the violent vibrations that plagued older liners at top speed. It was the mechanical heart of her ability to sustain 30 knots across the ocean. But for the United States Navy, this technological marvel came with a severe trade-off. The propulsion system was a highly specialized, sensitive, and intricate labyrinth. The original French crew had spent years mastering the eccentricities of her electrical switchboards, miles of cabling, and specific boiler configurations. The incoming American naval engineers were suddenly forced to step into a completely alien mechanical world. They had to decipher French gauges, translate operating manuals, and figure out how to maintain a highly temperamental power plant without the luxury of time or extensive training. Yet, the Navy was more than willing to accept the steep mechanical learning curve. Yurkevich's hull provided the speed to make submarine interception extraordinarily difficult, while her immense scale offered enough internal volume to theoretically carry up to 16,000 troops in a single crossing. A body of men roughly comparable to the personnel strength of a division, though not necessarily all of its vehicles, artillery, and equipment. But while the exterior of the Lafayette was the perfect military machine, her interior was a severe liability. To transport an army, the Navy could not use a floating palace. The magnificent soul of the ship had to be violently erased. The architects at the United States Navy's Bureau of Ships did not look at the newly acquired Normandy with awe. They looked at her with clinical military precision. The civilian vessel was the ultimate masterpiece of the 1930s Art Deco movement, world-renowned for her cavernous dining halls clad in hammered glass, bronze, and rare woods. But to the naval architects tasked with drafting the AP-53 troopship conversion, that luxury was an unacceptable waste of displacement. A new, urgent question drove their work. How do you safely convert sprawling luxury spaces into high-density military barracks without compromising the ship's core integrity? A warship cannot carry civilian excess into a combat zone. In the event of a bomb hit or a torpedo strike, decorative glass chandeliers and massive etched mirrors shatter into lethal, high-velocity shrapnel. Polished wood paneling, heavy drapery, and thick carpets become immediate fuel for uncontrollable fires. Bush ships dictated a ruthless requirement for the conversion blueprint. Everything that did not directly serve the survival, defense, or function of soldiers had to be violently ripped out. The conversion schematics called for stripping the grand dining rooms, winter gardens, and massive lounges down to bare steel. In their place, contractors would weld thousands of tightly packed, tiered canvas bunks, expand the mess decks, and build vast military supply lockers. Topside, the upper decks had to be structurally reinforced to support the heavy weight of anti-aircraft batteries necessary to fend off Luftwaffe attacks as the ship neared the European coast. The advantage of this massive gutting operation was undeniable. It maximized the ship's internal volume, instantly multiplying her capacity from roughly 2,000 pampered civilians to a staggering 16,000 combat-ready troops. But this extreme transformation carried a severe, hidden trade-off. The Normandie had originally been celebrated for her breathtaking, unbroken internal vistas. Her main dining room alone was longer than the Hall of Mirrors at Versailles. As the military conversion removed decorative partitions, fittings, and doors to make room for troop accommodations, the ship's internal arrangement was heavily disrupted. But the later spread of the fire would depend just as critically on open doors and windows, active ventilation, combustible material, and the strong wind outside. The unfinished conversion left the upper decks unusually exposed to rapid fire spread. The Bureau of Ships had drawn a logical, mathematically sound blueprint to win a war. But an engineering drawing is only a theory until it is executed. On paper, erasing the palace to build a troopship was a triumph of military logistics. In the shipyard, handed over to a massive workforce operating under an impossible wartime deadline, that same blueprint was about to become a deadly trap. By early January 1942, Pier 88 in Manhattan had been transformed into a frantic industrial battleground. The physical execution of the ship's blueprint was awarded to the Robbins Dry Dock and Repair Company, a civilian contractor tasked with tearing the soul out of the massive hull. But as the heavy labor began, the prospective commanding officer of the USS Lafayette, Captain Robert G. Coleman, arrived to take over the ship and immediately encountered a dangerous institutional fracture. Coleman and his skeleton crew of naval engineers were supposed to be preparing the ultimate American warship for combat. Instead, they inherited a chaotic, three-way jurisdictional tug-of-war. The United States Navy owned the vessel and was trying to prepare its crew for the complex French machinery. The Coast Guard controlled important aspects of waterfront security, while Robbins Dry Dock directed much of the physical conversion through its civilian supervisors. As the 1942 investigations later revealed, the boundaries between these responsibilities were poorly defined, leaving authority fragmented and accountability dangerously unclear. Under normal conditions, this bureaucratic friction would have been resolved through careful planning. But the outbreak of the war introduced a relentless, unforgiving ticking clock. The military situation across the globe in early 1942 was deteriorating rapidly, and the War Department desperately needed massive troop ships to reinforce vulnerable fronts. Driven by strategic panic, Washington arbitrarily accelerated the conversion schedule. The Lafayette was ordered to be ready to sail by February 14, 1942. Coleman and the naval overseers warned that this accelerated timeline was physically impossible to execute safely. The sheer volume of steel to be cut and luxury fittings to be removed required months of careful extraction. But the demands of the war overruled engineering caution. The decision to prioritize the schedule over shipyard safety forced a devastating operational trade-off. To have any hope of meeting the February deadline, Robbins Dry Dock drastically scaled up its workforce. Approximately 2,500 civilian workers were assigned to the conversion, operating in shifts around the clock, while Navy and Coast Guard personnel added to the dense population aboard and around the ship. They worked in a darkened, freezing, and debris-filled labyrinth, often relying on temporary, poorly strung lighting because the main electrical grids were being heavily modified. Because there was no time to complete the conversion sequentially, tasks that should have been strictly separated were violently overlapped. Contractors were actively tearing out fittings and modifying pipes while military stores, including mattresses, provisions, life preservers, and other combustible material, were being brought aboard and staged amid the same unfinished conversion. The most severe consequence of this rushed overlap was the unregulated execution of hot work. Hundreds of civilian workers wielded oxyacetylene cutting torches to slice through steel stanchions, showering the decks with white-hot sparks and molten metal. In a standard naval shipyard, hot work was governed by rigid safety protocols. A dedicated fire watch would stand directly beside the torch operator, armed with pressurized hoses and fire extinguishers, ensuring the area was completely clear of combustible material. But inside the massive, cavernous spaces of the Lafayette, those fundamental safety protocols collapsed. The wider fire watch system was inadequate, inconsistently enforced, and dangerously dependent on improvised arrangements among the work gangs. Firefighting equipment had been disrupted as pipe fitters worked on the plumbing. Each authority assumed someone else was managing the emergency patrols. In reality, thousands of exhausted men were operating blind in a high-risk industrial environment filled with flammable debris. By the second week of February, with the impossible sailing date only days away, the conversion of the USS Lafayette was no longer a structured engineering project. It had become a massive, unmonitored powder keg. All it needed was a single spark. On the early afternoon of February 9, 1942, the abstract risks of the accelerated timeline became a terrifying physical reality. In the heart of the ship lay the Grand Lounge. Once celebrated as the most magnificent room afloat, the space had been stripped down to a massive, echoing steel cavern. The cavern was being used as a temporary staging area for military stores. Stacked in the center of the darkened room were more than 10,000 life preservers, tightly wrapped in burlap bales. These military preservers were filled with kapok, a natural plant fiber prized by the Navy for its extreme buoyancy. But kapok possessed a deadly trade-off. Once ignited, the dry fiber and its burlap coverings could support a rapidly spreading fire and pour dense, choking smoke through the compartment. Just after 2:30 in the afternoon, a civilian contractor from Robbins Dry Dock was ordered to cut away 4 heavy steel stanchions in the lounge. He ignited his oxyacetylene torch. No dedicated fire watcher stood over the final cut. A worker had been using an asbestos shield to catch sparks, while a metal shield around the stanchion had been moved as the severed section was prepared for lowering, leaving the life preserver bales exposed at the critical moment. As the torch sliced through the steel, a sudden shower of white-hot slag cascaded past the makeshift shield and landed directly on the burlap bales. The kapok ignited instantly. Workers desperately attempted to stamp out the flames, but the oily fibers burned too aggressively. They sprinted to the nearby fire stations, unspooling the ship's canvas hoses and throwing open the brass valves. Nothing happened. The hoses were bone dry. The ship's fire protection network could not deliver an effective response. Alarm circuits and equipment had been disrupted during the conversion. Some hoses were dry or weak, fittings were missing, French and American connections were not always compatible, and the loss of reliable power further crippled the system. The mechanisms meant to contain a fire had been left fragmented, partially disabled, and unready for an emergency. Unable to fight the blaze, the workers fled as the fire capitalized on the ship's violently altered architecture. By tearing out the civilian partitions, fire doors, and luxury bulkheads to maximize troop space, the conversion had inadvertently created a perfect wind tunnel. The sweeping, unbroken horizontal promenades and vast vertical stairwells acted as massive chimneys. They drafted the fire, pulling in fresh oxygen and rapidly pushing the flames forward. Within minutes, the blaze ripped out of the Grand Lounge, tearing through the debris-filled passageways and consuming the upper superstructure. Below decks, Captain Coleman and his naval engineering crew attempted to mount a desperate damage control effort, but they were completely outmatched. Pushed back by a sheer wall of heat and suffocating black smoke rolling through the open corridors, the crew was forced to evacuate the hull. The internal battle was lost. The disaster now belonged to the massive fleet of New York fireboats and city fire engines aggressively converging on Pier 88. The fire burning through the upper decks of the USS Lafayette was devastating, violently erasing millions of dollars of engineering. But the flames alone would not sink the greatest prize in the United States Navy, the water would. As the winter sun set over Manhattan, the New York Fire Department mounted a staggering offensive against the blaze. From the street and from a fleet of fireboats in the frozen Hudson River, high-pressure monitors pumped an estimated 6,000 tons of water directly into the upper superstructure of the USS Lafayette. The firefighters successfully beat back the flames, but the immense volume of water retained high inside the ship created a developing stability crisis. To understand why the firefighting effort doomed the ship, one must look at the specific physics of her original civilian design. The key measurement was her metacentric height, the measure of how strongly a ship initially tends to return upright after a small heel. Salvage engineers later estimated Lafayette's initial metacentric height in the relevant condition at less than 1 foot, leaving a limited margin as thousands of tons of firefighting water accumulated high inside the hull. Whatever advantages her original stability characteristics had offered in passenger service, they now left the damaged and partially converted ship acutely vulnerable to added topside weight and free surface. Some firefighting water could escape through drains and scuppers, but the volume being poured aboard far exceeded the ship's ability to shed or pump it away. Debris may have obstructed portions of the drainage system, while the increasing list caused water to collect across broad, upper-deck spaces and allowed additional flooding through openings that were gradually being submerged. A widely repeated account places Vladimir Yorkovich outside Pier 88 as the disaster unfolded, urgently trying to reach the officials directing the response. According to that version of events, the designer understood the danger posed by the mounting topside water and sought permission to offer advice. But the full gateside scene is not clearly established. Whatever advantages her original stability characteristics had offered in passenger service, they now left the damaged and partially converted ship acutely vulnerable to added topside weight and free surface. Some firefighting water could escape through drains and scuppers, but the volume being poured aboard far exceeded the ship's ability to shed or pump it away. Debris may have obstructed portions of the drainage system, while the increasing list caused water to collect across broad upper deck spaces and allowed additional flooding through openings that were gradually being submerged. A widely repeated account places Vladimir Yorkovich outside Pier 88 as the disaster unfolded, urgently trying to reach the officials directing the response. According to that version of events, the designer understood the danger posed by the mounting topside water and sought permission to offer advice. But the full gate side scene is not clearly established in the surviving official investigation. The account holds that port security refused him access, leaving the man who had shaped the ship to watch from outside. Yet even if his warning reached the response teams, corrective flooding was no simple guarantee. Navy officers considered counterflooding, but the ship lacked convenient seacocks and scuttling valves for the task, while uncontrolled water was already entering through openings on the low side. Inside the hull, the trapped water was about to trigger the final, fatal mechanism, the free surface effect. The thousands of tons of water pooling on the vast, sweeping promenade decks did not just sit still as dead weight. Because the immense Art Deco spaces had been stripped of their dividing bulkheads to make room for troops, the water was free to slosh unbroken across the entire width of the ship. As the tide changed and the weight of water continued to shift inside the hull, the ship's list steadily increased. Instantly, the trapped water surged violently to the lower side. This massive, shifting fluid weight actively worked against the ship's center of gravity, physically dragging her further over. By midnight, the Lafayette was listing at a severe, unrecoverable angle. Captain Coleman and the Navy engineers recognized that the list was becoming unrecoverable. But with the ship's power plant dead and open cargo ports and smaller airports progressively dipping beneath the river, they were powerless to halt the accelerating downflooding. The architecture of luxury, violently stripped and filled with the very element she was built to conquer, finally surrendered. At 2:45 in the morning on February 10, the pride of the transatlantic fleet groaned under the immense strain, rolled over onto her port side, and died in the freezing mud. When the morning sun rose over New York Harbor on February 10, 1942, the United States Navy was forced to confront the immense strategic cost of its own haste. The loss erased what might have become one of America's most valuable high-speed transport assets. The United States and its allies continued to depend heavily on Queen Mary and Queen Elizabeth for major troop movements, but those liners formed only part of a far larger transport system, and their voyages could be independent, escorted, or connected with convoy operations according to the circumstances. A naval court of inquiry and a subsequent congressional investigation immediately convened. While the public and the press panicked over rumors of Nazi spies and sabotage, the official hearings revealed a much more frustrating truth. The hearings instead traced the loss to preventable institutional failures. The investigations delivered a blistering indictment of that fragmented command structure. The disaster did produce an immediate institutional response. On February 26, 1942, President Roosevelt placed responsibility for waterfront protection under the Navy Department, with the Coast Guard Commandant exercising that responsibility under naval authority. The loss reinforced the need for clearly assigned command and accountability during major conversion and repair projects, along with stricter control of cutting and welding through dedicated fire watches, removal or shielding of combustible material, ready firefighting equipment, and clear responsibility for emergency protection. The loss of the giant liner ensured that no American warship would ever be converted under such reckless, unregulated conditions again. But the ruined Titan still had to be dealt with. The capsized hull was a massive hazard to navigation, completely blocking one of the most vital military embarkation piers in New York. The Navy was forced to launch one of the largest, most expensive, and most difficult salvage operations yet attempted. Over roughly 18 months, scores of Navy and civilian divers worked in freezing water and near-total darkness, confronting contaminated compartments, entanglement hazards, unstable structures, and pockets of dangerous gas. They worked blindly inside the submerged hull, sealing open portholes, patching the deck, and building heavy timber bulkheads. The Navy nevertheless turned the wreck into an extraordinary practical training ground, developing scores of officers, divers, engineers, and salvage specialists through the daily struggle to raise the ship. The experience gained in clearing mud, sealing vast openings, controlling buoyancy, and righting Lafayette strengthened the Navy's wartime salvage capability. Personnel shaped by the project later contributed to emergency repair and harbor clearance work overseas, including operations in the Mediterranean and Western Europe. By August 7, 1943, after months of cutting away ruined superstructure, sealing openings, building temporary bulkheads, managing ballast, and pumping the hull in carefully controlled stages, the operation reached its most dramatic milestone. The enormous hull had been substantially brought upright. But the triumph of the salvage effort only confirmed the final tragedy of the ship. Once the water was cleared Inspectors found that her intricate machinery had seriously deteriorated after the fire, prolonged immersion, contamination, and months spent beneath the harbor. Her hull and internal structure had suffered extensive damage from the fire, the capsize, prolonged bottom contact, flooding, and the immense stresses of the salvage operation. Restoring her as a troopship would demand enormous amounts of money, skilled labor, machinery, and shipyard capacity at a moment when those resources were urgently required elsewhere. By the time she had been righted and assessed, the strategic need that had once justified the conversion no longer outweighed the condition of the wreck. The hulk remained in Navy custody through the rest of the war. Lafayette was finally struck from the Navy list on October 11, 1945. In October 1946, the stripped, rusted remains of USS Lafayette were sold and taken to Port Newark, New Jersey. There, the greatest masterpiece of civilian naval architecture was dismantled piece by piece, a process that continued into 1948. She was a magnificent machine built to outrun the enemy, but she could not outrun the institutional panic of her own creators.